Voilà, bienvenue à Let's Build It Zambia. Today we conclude on the introduction, that is section D of our introduction on Acrow Panel Bridge 700 XS. Of course, I'm your presenter, Samuel Hampongo. Okay, we introduced the Acrow Bridge, and today I present to you the pictorial views of what we usually talk about. Okay, so from the picture that we are using on our cover page, you can see the bridge has been launched across the gap. The bridge is seated on parkings. Okay, so at this particular point, the last piece of work that is remaining is simply jacking the bridge down. But on our introduction, we introduce you that the space between this abutment and the far abutment is what is known as a gap. So we said for an Acrow bridge 700 XS, it can have a span ranging about 60 meters to 91 meters without the need of intermediate piers. After 91 meters, you will need to introduce intermediate piers or introduce an Acrow bridge, which is known as a multi-span Acrow bridge. Okay, that was all on our recap on introduction. Okay, or to also bring it back home, we introduced panels as the main basic building elements of an Acrow bridge. We haven't yet started talking about the major components of this bridge. We simply introduced panels. And today we will give you a pictorial view of how panels look like. So voila. So this is our bridge that is about to be launched. It's been assembled on the home bank. It's been assembled on the home bank area, and the bridge is booming or pushed towards the gap where it will finally be launched or on the gap as a bridge. Okay, so we've seen that there are panels all over. You can see these are panels, the ones I introduced you to as the main elements that give the stability of this bridge. So here we go. An Acrow Bridge 700 XS has got what are known as truss panels. These are truss panels. So what you are seeing on your screen as truss panels. So of course, these panels, though they look the same, they are not the same. Okay, there are three types of truss panels, and these panels we have an AB701 truss panel, we have an AB702 truss panel, shear panel, and there's an AB708 high shear panels. Okay, so these, though they look the same, they differ. If you look closely on the image below, you're going to see that this panel here is a bit different from this panel here. We'll look at those details more in depth when we begin the major components of an Acrow bridge. So far, just know that there are truss panels, and there are three types of truss panels, and these are the panels you're seeing here. Now, these panels, when they are placed on the bridge, they are not placed, they do not make up a single line of just one panels. No, usually they are placed, there is an inner truss system, which is this part you are seeing here. It will run from this home bank all the way up to the far bank that side. This is called the inner truss system. The inner truss system, there's also an outer truss system. So these two truss systems, inner truss system, outer truss systems, are braced together or linked together by these components that we are seeing, these bracing members here, okay, known as rakers. So we'll come to identify all these parts, we'll come to know them. But just know that the inner trusses are placed together with outer trusses. Of course, you have a footwork. This is a footwork component here, footwork component, which we'll also talk about, and this is now the actual roadway of this particular bridge. So these trusses, we have inner trusses and outer trusses. Among the types of trusses we have for an Acrow bridge, we have three types: an AB701 panel truss, we have an AB702 shear panels, and also we have an AB708 high shear panels. Okay, so we move on. Now, we give you a pictorial view of the center of this Acrow bridge. So usually you have this roadway of your Acrow bridge, and you have these panels here on the sides. Okay, so to give it more strength, I'm just introducing it generally. To give it more strength, you can introduce on top of the panels, you have what are known as reinforcement cords. These are reinforcement cords on top of our truss panels. That is after the first bay. Remember, I introduced you to bays, and I'm going to show you again pictorial view. So this is an Acrow bridge. You have, this is the roadway, and this roadway, I gave you the dimension size for a single lane, for 2 lanes, for 3 lanes. It goes even up to 4 lanes of an Acrow panel bridge. Okay, so here we go. So you can see this roadway here. Okay, so now remember I told you that this is the first panel here, which is placed, which sits on the bearings. Okay, this is the first panel which sits on the bearing, or let's say on the abutment. This is where the home bank begins. So this first set of panels that are placed at the end of both home bank and far bank, this first bay here from this side and also on the behind us is the first bay, and this set of panels are what are known as shear panels. So for shear panels and high shear panels, they are placed at the abutments, the beginning of the actual bridge proper. Okay, these shear panels are different from these panels after the first bay. Okay, after the first bay, these bays, these are truss panels, AB701 panels, while these can be AB702 or AB708 shear panels. They are different. Why? How? One of the ways in which shear panels are different from these normal AB701 panels is that these shear panels consist of heavy bracing members. These shear panels are heavier than these other bays. The first bay is heavier than these other bays after the first and the last bay. Okay, so just know that there's a difference between the first bay. Okay, we have shear panels which are placed on the first bay, then followed by normal AB701. Okay, if you look at these cross sections here, these tubes, these square tubes, these are square tube sections here. Okay, they are square tube sections. They are square tubes. But if you look at these are channel sections. Okay, so the sections, intermediate sections for AB701 truss panels are different in that the ones for shear panels, they have got square tubes. They are square tube. While those for AB701 normal panels, they have got tubes that, I mean, they've got uh, U-shaped U-shaped channels. And for shear panels, they have heavier bracing members, while these other normal panels after the first bay, they are lighter. So that is a quick up an addition to our introduction. Then the other thing to take note of is that we introduce you the distance of one bay, or the distance of one truss panel. From this particular point to this particular point, you have 3.048 meters. 3.048 meters. Go back to the introduction to take note. And the height is 2.29 meters. So this is 2.29 meters, like that. So that is the size of the truss panel. Voila. Okay, so in between the truss panels, between the inner truss panel and the outer truss panel, you will have these beams. I introduced you to these beams, beam-like members, which are known as transoms. These are transoms. Okay, so transom comes every after a bay. Okay, so meaning if the size of a truss panel is 3.048 meters, meaning every after 3.048 meters, you place a transom, these horizontal beams. These beam-like sections, they help to hold together the inner and the outer truss sections. Okay. and also structure-wise distributes the load of the bridge deckings, okay, in half and distributes to the inner and outer trusses, which further transmits the load to the abutments and further to the soil on the ground. So these are known as transoms or beam-like sections placed every after 3.048 meters. So on top of the panels, you have what are known as reinforcement cord. I introduced reinforcement cord. And these reinforcement cord begin after the first bay. After the first bay, on top there and on the bottom there, you have what are known as reinforcement cords. The purpose of reinforcement cord is to strengthen the bridge. Remember, the aim is to intercept that bending moment, and not only intercept the bending moment, but also increase the moment of inertia of the bridge. So these are transoms. Between the transoms, you have bracing members, sway bracing members. We'll talk about all these when you introduce major components of the bridge. You have these bracing members, okay? The purpose of the bracing members to overcome that shear effect, okay, and also to hold this, to maintain that shape in between. Maintain and avoid that shear effect, okay? Okay, between these transoms like that. So here we go. These are sway bracing members. Okay, you have also transom bracing members this side. So you have these bracing members, you have those bracing members. Okay, in between the inner trusses and the outer trusses there, you also have some bracing members or some rakers like that. Okay, so that is the pictorial view. You can see these bracing members, okay? Bracing members, you see bracing members on this other side. Every after 3.3 meters after a bay, you have a transom like that. Then on top of the transom, you have these units known as decking units. Okay, this is the roadway. These are decking units, which are also placed on top of transoms. These decking units, on top of them, you have what is known as rough epoxy. Okay, this is rough epoxy to make sure that our vehicles do not skid or slide on the surface of our Acrow bridge. Okay, so here we go like that. So these are called decking units. Okay, decking units, which is the roadway surface of the bridge. Okay, so that is after we have placed the entire area, the entire roadway with decking units, then we fasten the decking units. Okay, so these inner truss and outer truss, inner truss and outer truss. On top, you have reinforcement cords. Okay, now we talked about the size of the lane. For a single lane, we said it's 4.2 meters for a single lane. If it's a single lane, if it is a single lane that is a extra wide single lane, for an extra wide single lane, it can be 5.5 meters. So for a single lane, according to an Acrow bridge standard, the minimum is 4.2 meters. If it is an extra wide single lane, same Acrow bridge, we get 5.5 meters. For a double lane, you can have the minimum, which is 7.35 meters. And for a double lane, maximum is 9.15 meters. We introduced this in the first part, subsection A of our introduction. Okay, so this is 4.2 meters, okay, the road width. Okay, then of course I introduced you to the height of these truss panels, which was about 2.29 meters. Okay, so again, you can see this is a transom, and that's another transom. Every after a bay, a transom. Okay, you can see that these single bays, this bay, okay, so this truss panel, okay, is parallel to that truss panel. These two panels make up what is known as a bay, B-A-Y. That's a bay. So this one here, together in tandem with that one, make up the second bay. From this one up to the next one, also opposite, they make up a bay. So here you have bay 1, bay 2, bay 3. Of course, this consists of what is known as the launching nose. That's why there are no outer truss. Have you noticed that there are no outer truss systems? There's no outer truss, it's just the inner truss. Okay, this inner truss, when you see, the reason why there's no outer truss is because this is the launching nose. The launching nose is the one that assists us to overcome the turning effect during the booming process or the launching process. Okay, as you can see, the bridge is about to be launched, and these here on the wheels here, these wheels which are placed on the surface of the bridge cape, this is a bridge cape. Okay, these are known as rocking rollers. Rocking rollers here. There are two rocking rollers where the bridge sits and slides as we are pushing it and launching it on our gap. There's this rocking roller, and also another side there's another rocking roller like that. So this is the roadway. Outside the roadway, you also have the footwalk system. There's a footwalk system. It can either be on one side or on both sides. There's a footwalk system like that. So that was an overview on introduction. We've introduced you to the sites. We've introduced you briefly to some bracing members. We've introduced you to some, apart from bracing members, we've introduced you to also some uh, uh, these launching members, okay, such as the rocking rollers that we have seen. We introduce you to also to the plain rollers. We introduce you also to the shear. We introduce you to all the other components necessary. So this was the last part on our introduction. Voila, and see you now as we look at all the bridge designs and the other components that we are going to look at as we begin the entire process. Voila, à toutes.